So, with the fourth unit syllabus, I hope we have discussed till TCP timer management. Okay, so I'll continue with the next topic, that is TCP congestion control. Just a minute. Okay, so what is TCP congestion control? What do you mean by congestion? Congestion is nothing but when the load offered to any network is more than it can handle, then we say that the congestion occurs in the network. It means that it is beyond the capacity of the network. The load offered to the network is beyond the capacity of the network. So we call it as congestion. So what are the causes for congestion? So congestion may be caused due to several reasons. So the simple reason we can consider, like when the queues grow large at the routers. So when the router is not capable of handling the amount of data which is being received, so then we can say consider it as a congestion. So we have different mechanisms with TCP to control congestion. So what are those mechanisms? We have AIMD rule, we have slow start congestion control mechanism, fast retransmission, and fast recovery. So this we'll be discussing in today's class. So we have see, for in order to control this congestion, we need some parameters. So what are those parameters? See here with the TCP considers two different parameters. One is congestion window, another one is flow control window. So what is congestion window? So congestion window is nothing but the size of the congestion window will be set to some value, and similarly we have a flow control window. So congestion window indicates what will be the amount of data the sender may have in the network at any time. Okay, so that we call it as a congestion window. So that means the size of the congestion window is set to the number of bytes the sender may have in the network at any time. And what is flow control window? Flow control window is nothing but the number of bytes the receiver can buffer. Okay, so whenever TCP need to handle the congestion in the network, okay, so it checks with the both the windows, that is congestion window as well as flow control window. Okay, so congestion window indicates the number of bytes the sender may have in the network, and flow control window indicates the number of bytes the receiver can buffer. These two windows are tracked in parallel, and the number of bytes that may be sent on a network will be the smaller of these two windows. So suppose we consider any size of or amount of data to be sent. Okay, so then we have already discussed with the window management in TCP. It means that the sender and receiver will check with what is the availability of the buffer at the receiver side, and based on that the sender is going to send the data, right? So similarly here, considering the congestion window and flow control window, the sender will send the data so that the congestion means the data which is sent will be the smaller of these two windows in order to reduce the congestion. Okay, so these two windows will be set to some values, and these are tracked in parallel so that at any point of time in the network, the data sent will be the smaller of these two windows. So these two parameters plays a major role with the TCP congestion control. That is, one is congestion window and flow control window. See, this congestion window can also be defined as a parameter like a window size divided by RTT. So window size is nothing but what is a buffer available at the receiver, and divided by RTT is nothing but round trip time. So this parameter can define the size of the congestion window. So earlier it was called as congestion collapse. Congestion collapse is nothing but it is a period where the throughput of the network will be dropped due to congestion. See, congestion to for the congestion to occur in the network, there are several parameters. Okay, so considering those, see, whenever we say there is a congestion in the network, definitely it reduces the throughput of the network. So good put is nothing but it is nothing but it is representing throughput of the network. So congestion collapse is nothing but it is a period where the throughput of the network is dropped. Okay. So TCP consists or considers these two parameters in order to check with the congestion. Next we have see, there are some congestion control schemes which are implemented and which was proposed by Jacobson. So what are those? So one is AIMD rule. So what is this AIMD rule? This is one of the rule which is used to control congestion in TCP. So approximating AIMD congestion window. So what do you mean by AIMD? It is nothing but additive increase and multiplicative decrease. Additive increase and multiplicative decrease is nothing but, see, whenever there is no congestion in the network, then the congestion window size will be increased so that it accommodates more amount of data. So whenever there is a congestion, then there is a multiplicative decrease. Multiplicative decrease means exponentially the congestion window size will be reduced in order to, means which indicates that there is a congestion in the network. See here, AIMD rule is linear growth of congestion window when there is no congestion and exponential reduction when congestion is detected. Okay, so here the congestion window is taken as a parameter in order to check with the congestion. So whenever there is a increase in the congestion window size, then it indicates there is no congestion. So whenever there is a congestion in the network, then it is multiplicatively decreased. Multiplicatively decreased means the congestion window size will be decreased. So that indicates the congestion. So here, how to whenever we say there is a congestion, it means that the packets are lost, right? So here the packet loss is considered as a signal for congestion detection. I hope you are following. So AIMD rule is nothing but a linear growth of congestion window when there is no congestion. For example, linear means one by one. For example, if you say the congestion window size is 10, okay, so next time if there is no congestion, it goes on linearly, means plus one like that. You say like increment operator, right? It is nothing but it is going to increase the value by 1. Linear growth means it is in a smaller amounts of uh, values, whereas multiplicative decreases, it is exponential reduction. Okay, so this is AIMD rule of controlling the congestion. So all TCP algorithms, all internet TCP algorithms assumes that lost packets are caused by congestion, and here TCP is using many different types of timers. So here, whenever the congestion occurs, it means that the packets are lost. Okay. So how, in case of TCP, those lost packets will be retransmitted, right? So how the retransmission is done? So TCP maintains a retransmission timer. Okay. So what is that retransmission timer? So it waits for some time. So if the acknowledgements are not received, then it indicates that the packets have been lost, and again the packets need to be retransmitted. So you know the difference with TCP and UDP. TCP has a retransmission facility, so the packet loss is less in TCP compared to UDP, right? So here, that is the role of the retransmission timer in order to detect the packet loss and retransmit the lost packets. Okay, so a good retransmission timer is needed to detect packet loss signals accurately in a timely manner. Okay, so we have discussed with the retransmission timer and other types of timers associated with the TCP function. So here in case of congestion control, so retransmission timer plays a major role. Why? Because it need to detect the lost packets, and then it need to retransmit the lost packets within the given period, okay, before the retransmission timer expires, right? So here acknowledgement clock also plays a major role. Acknowledgement clock is nothing but, see, we need to check with the timing when the packet is transmitted and when the acknowledgement is received, right? So once the acknowledgement is received, it guarantees that the packet is delivered. If the acknowledgement is lost, then it indicates that the packet is lost, means it means the packet is not delivered. So here with the congestion control mechanism with respect to AIMD rule, so you need to consider with the parameter of congestion window. So where the congestion window indicates whether there is a congestion or not by increasing or decreasing the value of the congestion window. So whenever there is an increase in the congestion window value, linear increase, it indicates there is no congestion. Whenever there is a decrease, it indicates congestion. Okay, so next we have a slow start mechanism. So with the slow start congestion control mechanism, see what we discuss now, it is a AIMD rule. So this is slow start mechanism. Slow start mechanism is one of the congestion control mechanism which is used with the TCP. Okay, so what is this slow start mechanism? See, whenever the connection is established, the sender initializes congestion window to a small initial value of at most 4 segments. Okay, so here we have a sender and receiver. So this is this is sender and the other side is the receiver. So there is a connection which is established between the sender and the receiver. So whenever the connection is established, the sender initializes congestion window to a small initial value of at most 4 segments. Okay, so the initial window congestion window size is of 4 segments. It means that it can accommodate 4 segments. So with the TCP, we call it as the data unit as a segment. So initially it is set to 4 segments value. So after the sender initializes the window size, that is the congestion window size. Okay, so then the packets are sent. So here you can consider at the first step, the congestion window size is 1. Okay, so it is going to send the first packet. So after receiving the acknowledgement from the other side, okay, so here with respect to slow start congestion control mechanism, okay, so for the next time, whenever the acknowledgement is received, for the next clock cycle, it can allow 2 more segments to be sent. Means congestion window is doubled with every RTT. Okay, so initially the congestion window size is 1. After it receives the acknowledgement for the first packet which is sent, then the congestion window will be doubled. Okay, so here you can see the congestion window is doubled with every RTT. Okay, so just a minute. Okay, so initially it is 1. The first packet will be sent and the acknowledgement is received for that. So after that, the congestion window will be doubled. So here the slow start mechanism exponentially increases the congestion window. So every time it doubles the congestion window. Okay, so for the next time, 2 packets can be sent. So then after the acknowledgements are received from the other side, now you can see the congestion window is doubled. So in the previous it was 2, now it has become 4. It means that the 4 segments can be accommodated. Okay, so then again for the next clock cycle, the congestion window will be doubled. I hope you are following, right? Is it visible? The presentation is visible. So this is one of the mechanism of congestion control with TCP. So what is a slow start mechanism? So slow start mechanism initializes the congestion window value. So initially it will be set to at most 4 segments value. So that will be the initial size of the congestion window. So whenever the packets are transmitted, after the acknowledgement is received, then the congestion window size will be doubled. So the congestion window is doubled with every RTT. Every RTT is nothing but, say RTT is nothing but the time taken for transmitting the packet until the acknowledgement is received. Okay, so that we define it as an RTT, round trip time. Okay, so once the acknowledgement is received, so then the congestion window size is doubled. So slow start mechanisms causes exponential growth. So since it is the growth of the congestion window is exponential, so it allows more number of packets to be present in the network. So whenever we say there is a more number of packets and there is no limit for the congestion window, so we can say like the congestion may be more in the network. It means that the congestion window size goes on doubling every time. It is exponential growth. So then it leads to more number of packets in the network. So in order to put a control on that, so we can set some threshold value for that congestion window. So what is the threshold value? The threshold value is nothing but we call it as a slow start threshold. It means that, see, uh, whenever there are more number of packets in the network, or whenever there is a congestion, so the slow start threshold is set to half of the congestion window, and entire process is restarted. It means that, so whenever we have more number of packets in the network, okay, so this slow start mechanisms makes the congestion window to be exponentially grown. So when it is exponentially grown, then it allows more number of packets to be transmitted for that particular clock cycle. So when it is transmitted, so due to some, if the, for example, if the congestion window size is more, then since there are more number of packets in the network, there is a cause of congestion. So when such cases are detected, then the congestion window value will be reduced to half in order to control the congestion. That is the process with the slow start mechanism. Okay. So what is slow start mechanism? Initially, it is set to some value. What is that initial value? The 4 segments value. So once the acknowledgements are received, the condition window size goes on doubling. Okay, so at the situation where the condition is detected, then the condition window value will be set to half of the value. For example, if the value is 8, okay, so if it means whenever a condition is detected at that situation, the condition window value will be reduced to 4. Okay, half of that, so that it can hold only some number of packets. In order to avoid the condition, it is going to reduce the condition window to half of the size. So here, the congestion window plays a major role with the TCP congestion control mechanism. See, in order to control congestion, TCP needs to monitor both congestion window as well as flow control window. So in the previous class, we have discussed with the window management in TCP. That is nothing but the flow control window. Okay, so we were checking with the what is the size of the buffer available at the receiver and sending the data. So here, what is this congestion window? Congestion window is nothing but checking with the capability of the sender. Okay, so there with the flow control window, we check with the capability of the receiver. Whereas with the congestion window, we check with the what should be the amount of data that the sender can transmit at a time. Okay, so that we need to check. That is defined with the congestion window. So this congestion window and flow control window plays a major role with TCP congestion control mechanism. Okay, so this slow start mechanism, fast read, transmit, and recovery are the different congestion control mechanisms used with TCP. So what is fast read transmit? So fast read transmit and recovery. See, what is the drawback of slow start mechanism? Since slow start mechanism causes exponential growth, it will send too many packets into the network very quickly. Okay, so when such things happen, then there will be more number of packets in the network. So in order to control that, we have that slow start threshold value also. But even though in some cases it may not efficiently control, so in some cases like just a minute. So slow start mechanism, it's not so efficient as it increases the congestion window exponentially. So that is overcome with the fast retransmission and recovery mechanism. So what is this fast retransmit and recovery mechanism? So fast retransmit and recovery mechanism, it makes it possible to quickly recover the lost data packets. Okay, so here the packet loss acts as a congestion, means a signal for detecting the congestion. So whenever there is a packet loss, it tells that there is a congestion in the network. So packet loss itself is considered as a signal for detecting the congestion. So with the fast retransmission and recovery process, see when we say that the packets arrive in different order. Okay, so this TCP assumes that See, whenever the packets arrive out of order, so if there are three duplicate acknowledgements, then it implies that a packet has been lost. So it means that, so you can just read the sentence below here. If a receiver receives a data segment that is out of order, it immediately sends a duplicate acknowledgement to the sender. So whenever a data segment which is received, it is out of order, then it sends a duplicate acknowledgement to the sender. If the sender receives three duplicate acknowledgements, it assumes that the data segment indicated by the acknowledgement is lost, and it immediately retransmits the lost segment. Okay, so what is this first retransmission and recovery process? So if any data is arrived out of order, see, this is also one of the congestion control mechanism. When the data is received out of order, okay, so then the receiver sends a duplicate acknowledgement to the sender. So whenever the three duplicate acknowledgement are received for the segment which is being transmitted, so then it indicates that there is a congestion, or the congestion is nothing but the packet loss. There is a packet loss, and it immediately retransmits the lost segment. So it does not wait for the any retransmission timer to work. Okay, so immediately once the duplicate acknowledgements are received, it immediately retransmits the lost segment. So hence it is called as fast retransmission and recovery. So with the congestion window, means with respect to slow start, what is the mechanism? There we are going to concentrate on congestion window. So whereas with fast retransmission and recovery, so whenever the receiver sends any duplicate acknowledgements, the duplicate acknowledgement itself acts as an indication that the congestion is detected. It means that the packets are lost. So those packets will be immediately retransmitted. Okay, so hence it is called as fast retransmission and recovery procedure. So with the so this fast retransmission and recovery procedure, it does not work efficiently when there are multiple data packet loss. So when there are multiple data packet losses occurring over a short period of time, so this mechanism does not work efficiently. Okay, sorry, there was some network issue. See, overall description of TCP congestion control mechanism is, so we have several methods for controlling congestion with TCP. So basically what is congestion? Congestion is nothing but when the load offered to the network is more than its capacity, the congestion occurs. So here TCP uses two different parameters. One is congestion window, another one is flow control window. So congestion window is initially set to some value, and flow control window indicates what is the size of the buffer, receiver buffer, or what is the amount of data the receiver can hold. Okay, so these two parameters are used uh, to detect or to consider it as a parameter to detect the congestion. So how the congestion is detected? So packet loss is considered as a signal for detecting the congestion. Okay, so whenever a congestion occurs, we say the packet is lost, right? So packet loss itself is considered as a signal to detect the congestion. So here we have three different mechanisms, and we have another mechanism, AIMD rule. So all these four mechanisms are used for controlling congestion with TCP. So what is the first one? First one is AIMD rule. AIMD rule tells you that additive increase and multiplicative decrease. Okay, so this is going to consider congestion window as a parameter. Additive increase of congestion window when there is no congestion, and multiplicative decrease of congestion window when there is a congestion. Okay, so that is AIMD rule. Means the congestion window size grows linearly when there is no congestion, and the congestion window size decreases exponentially when there is congestion. Okay, so that is AIMD rule. So another one is slow start congestion control mechanism. So what is slow start congestion control mechanism? So initially the congestion window is set to some value. Okay. So after each packet is transmitted and acknowledgement is received, then the congestion window size doubles. Okay. So the congestion window size doubles, indicating that more number of packets can be sent. So initially, if you consider at the first clock cycle, one packet is sent and the acknowledgement is received, then the congestion window size becomes double. So you can set it to congestion window will size will be 2, then 2 packets can be sent. So after the 2 packets are received, means acknowledgement are received for those 2 packets, then again it will be doubled. It becomes 4. Okay. So then for the next time 4 packets can be sent, and again after all the again the acknowledgement are received for all those 4 packets. Again for the next time the congestion window size doubles, 4 becomes 8. Okay, so it means that it goes on increasing exponentially. So every time the congestion window size goes on increasing exponentially once the acknowledgements are received. So this is a drawback where if the congestion window size keeps on increasing exponentially, so there may be some situation like there may be where there are more number of packets in the network, so which causes congestion. So in such cases, so the congestion window size need to be decreased. Congestion window size need to be decreased in order to control the congestion. So for that, some threshold value is defined for the congestion window. So where if the congestion window goes behind the threshold value, then the congestion window size decreases in order to control the congestion. So that is with slow start mechanism. So with fast retransmit and recovery, so we say that the data on a network arrives on different paths, and it may arrive out of order. So with the TCP, we have fragmentation and reassembly concept. So reassembly is nothing but we are going to arrange all the data in an order at the receiver side. So your frame sorting technique program, what you have studied. So that is nothing but we are going to arrange the data in an order, right? So when in cases like when the data is arrived out of order, so then the receiver can send a message to the sender like that data is not a proper data, or if it is not in an order, it can send in order to indicate that it will send a duplicate acknowledgement. Okay. See, whenever the data is received at the receiver needs to send some acknowledgement to the sender, indicating that data is delivered. Okay. So if in case the sender is receiving any duplicate acknowledgements continuously, okay, so here it considers 3 duplicate acknowledgement as an indication. So if 3 duplicate acknowledgements are received, so then it indicates that some data is lost or data is out of retransmitted. Okay. So here with the congestion control, it is nothing but we are considering packet loss as a signal for detecting the congestion. So whenever the packet is lost and retransmitted, then it indicates that the congestion is controlled. Okay. So these are the different mechanisms for controlling the congestion with TCP. So we have another 2 parameters here. So what are those? TCP also uses selective acknowledgements and ECN. So what is a selective acknowledgement? Selective acknowledgements is nothing but the acknowledgement number. So it is agreeing upon some acknowledgements number. It means that the sender can decide what packets can be retransmitted or how to track the packets in order to implement the congestion window. So when the connection is set up, the sender and receiver, it sends an acknowledgement numbers which need to be understood by both the sender and the receiver. So based on those acknowledgement numbers, it is going to detect. So whenever the acknowledgement is received, based on the number in the acknowledgement, it can identify whether it is a proper data, whether the proper data is received or if it is a valid acknowledgement or not. Okay, so that is nothing but a selective acknowledgement. So based on the selective acknowledgement number, it can detect whether it is a acknowledgement received for valid data or not. So that is one mechanism. So another mechanism is use of ECN. ECN is nothing but explicit congestion notification. So this you have already studied. So here we have two parameters. One is ECE and ECWR. ECE is nothing but ECN echo. So whenever there is a congestion, so the host need to be notified about the congestion. So how it is going to notify? It is going to send some message. So that is nothing but ECE. ECE, it means that ECN echo. Echo is nothing but it is a form of message which is sent to the host in order to indicate or notify about the congestion. And also another parameter, congestion window reduced. Okay, that is CWR. So whenever there is a congestion, then the congestion window size need to be reduced. So these two parameters are also used with ECN in order to detect congestion. So these are the various methods of TCP congestion control. So what are the different methods? One is AMD rule, then slow start, fast retransmit and recovery, and also these selective acknowledgements and ECN can be used in order to control congestion. So when ECN is nothing but whenever there is a congestion, it is notified in the TCP header. So this ECN bit is used in the TCP segment header, right? And also the selective acknowledgements. Okay, so these are the different ways of controlling congestion with TCP. So detecting the congestion and then retransmitting those lost packets. So that is what which is done with all these congestion control mechanisms. So next we have World Wide Web, that is WWW. I hope all of you are familiar with this World Wide Web. So you are accessing many different web pages for accessing different types of resources. So what is World Wide Web? It acts as an architectural framework for accessing linked content spread out over millions of machines all over the internet. So using your internet, you are able to access all the different resources on different web pages, right? So what does this web page contain? Web page contains some data which is in the form of text, audio, video, or some links. So this idea of having one page point to another was designed or invented by the person named Vannevar Bush. Okay, so that is nothing but we call it as a hyperlink. Hyperlink is nothing but say when you are accessing one particular web page, in order to go to the another web page or the content which is linked to that, you are going to just click on some link. So that we call it as a hyperlink. So that idea of that hyperlink was invented by this person, Vannevar Bush. So how we are going to access your web pages? These web pages are accessed with a program called as a browser. So what is a browser? So you are using many different browsers on your mobile phones or any type of computer device, that is Firefox, Internet Explorer, Chrome. All these are nothing but the browsers. So this is nothing but a program, so which is used to access your web pages. So what does a browser do? The browser fetches the page requested, it interprets the content and displays the page properly formatted on the screen. Okay, so the role of the browser is to fetch the particular page which is requested and interpret the content. So what is the content on that particular web page and displays it in a proper format. Okay, so according to the user interface required on that particular web page. So this is I hope all of you are familiar with this web pages. So there are some basic concepts, basic things to be discussed. So what is hyperlink? Hyperlink is nothing but a piece of text, icon, image, and so on associated with another page is called as a hyperlink. So you can see some links which are available on some web pages. So when you click on the link, it will take you to the another web page where you have the content related to what you requested for. So that is nothing but an hyperlink. It is going to contain some text data or image or icon or something else like that, and each page is fetched by sending a request to one or more servers which respond with the contents of the page. So whenever for example on a Google server, whenever you type some links or request for some content, so it will take it is nothing but it is a request which is sent to the particular server. Okay, it is sent, the request is sent to the server and the server will reply back with the whatever the content requested for. So this we call it as a request response protocol. Okay. So the content what you require, you're going to type it and click on enter, or that is nothing but a you're going to give a request. So whenever that request is submitted, there are some steps of processing how that request is processed. Okay, so that request will be sent to the server. Okay, so that server will reply back with the content. So the request response protocol for fetching pages is a simple text based protocol that runs over TCP, and it is called as HTTP. So the protocol which is working with your fetching of web pages or your request, all those request response services is nothing but HTTP protocol. The content on the web page may be either a document or the result of a database query or a program execution. So you find many different resources available on web pages. Okay, so different types of content are present. So this page may be either a static page or dynamic page. So static page is nothing but, so whenever you access that particular web page, the information remains same. Okay, so dynamic web pages, the information keeps on updating on that particular page. Say for example, news. Okay, so every day you get a latest news. So all those latest news will be updated on the dynamic means the web pages. So that is nothing but we call it as a dynamic web page, means the content keeps on changing frequently. So where the static page, so whenever you access that page, the content remains same. Okay, so that we call it as a static page. You may have either a static web page or dynamic web page. So how do you identify the particular web page? Each page is assigned a URL. So URL is nothing but uniform resource locator that effectively serves as the page worldwide name. For example, www.google.com. So that is an URL to access your Google, right? So this URL has three parts. What is that? The protocol, the DNS name of the machine, and the path. Okay, see, the protocol is nothing but HTTP. We have different types of protocol associated with particular applications, that is HTTP, FTP, SMTP. Similarly, we have other protocols. So the protocol indicates what is the, it is also known as scheme. Okay, so here with your all web pages, the protocol used is either HTTP or HTTPS. You know what is the difference with HTTP and HTTPS? HTTP is secure, and the path uniquely indicate the specific page. Okay, it is a path name, so it is similar to that of your. So whenever you are working with some directory, so you are going to specify some path name. So similarly, when you request some content on a server, it is going to check with the path of that particular server. That path will be displayed in the header. You can see with the where you are going to type the email, that URL. So once you request for some content, you can see some a line which is displayed in the header. Okay, so which consists of a link or path to that particular server. Okay, so for example, if you are accessing your college website edu.in, so in that if you are going to search for computer science department, you'll find the link like /department or /CSE /syllabus, something like that. Okay, so that is nothing but a path name, so which is indicated as a part of your URL. So this URL points to one specific host, but sometimes it is useful to reference a page without simultaneously telling where it is. Okay, so instead of pointing to the particular host. Okay, so it points to some different servers. So where those servers are located. So these URLs are replaced by the name called URI, that is Uniform Resource Identifier. So these URI tells us how to locate a resource, so or where that particular resource is found. Okay, so for this, for designing these web pages, so these web pages are written in a standardized language called HTML. I hope you know the HTML. So this HTML we'll discuss it later. So for your internals, just to study with the theory part of the www, that is the architecture of www. So that I'll discuss it in the next class. So in the tomorrow's class, so I'll end up the class today. So for tomorrow's class, we'll discuss with HTTP and DNS and FTP. Okay, so in the tomorrow class, I'll discuss it all those three concepts. So later, when you're coming for the class on Monday, so I'll just brief out all the topics which are required for your internals. Okay. So I'll stop the class. I hope you have understood. When you come on Monday, once again, I'll brief with the contents. Okay. So if you listen now, then that will be like a revision for you, or you will get an awareness of that particular topic. So I'll share you the assignment questions by today afternoon. Okay. So go through those questions, and if possible, you write before your internal so that you can study from that. So and submit that assignment after your internals. Okay. So tomorrow I'll take the class at same time at 11 o'clock. Okay. So if any changes, I'll let you know. Okay? I'll inform Sri Charan so that you can attend the class according to that. Okay. Thank you.